Welcome guys, thank you for watching this video, but before we proceed, do not forget to subscribe, turn on the notification bell, like this video, share it to all of your friends, and also check out the description for further information guys. And now, let's get into the video.
Alright guys, so welcome to today's video, and today we will continue our vampire mask from the last video. And let's just quickly recap what we have done. So we have created this vampire mask within Blender, and we have made the mask clone the vampire attacks local script. Okay, now in this video, we are going to script these attacks, of course. Alright, so let's get started with this one. Alright, let's go inside of our local script right here. And yeah. So the first thing, or the first variable which we are going to define is the remote event. And the remote is going to be script remote. Script remote, okay? So we are going to fire server this remote event, and this fire servering will lead to the creation of the attacks. Of course, it depends on the parameters you insert within this fire server. So let's say you fire server with an argument called I don't know, laser eyes maybe. Then our character is going to shoot out his laser eyes, and so on. All right. Now the second thing is the user input service. This is a service which is responsible for detecting the user's input, and we are going to use this service in order to detect when the player has pressed a certain key. So user input service, input began, which is an event. So if any input has been done, then this function, or this event right here is going to do the following code, which is in between these two things. And this code, wait. So we are basically receiving two parameters. The first parameter is the input, I think, and the second parameter is the game processed event. So we just check if the input was not done while using the chat or interacting with GUIs, because we really want to see if the player really the player really has the intention to attack, and if the player is typing in a chat and just presses the key which is responsible for an attack, then it does not mean that the player really wanted to use the attack just because he has pressed the key, So that's basically what we are preventing by making use of this GPE thing. So if it's not GPE, it means the player hasn't used any GUIs, hasn't used the chat, and clicked the key within that, which means on the other side that the player really wants to use the attack. Then we want to check if the input key code equals unum key code, and now our first key which we want to use for the vampire. So I'm gonna use the F key for the first attack, and this one is going to be the laser eyes thing. Now let's select the second key. So input key code, this time let's say G. And this one is going to be the freeze attack. And now the last one, let's say H. And this one is going to suck out the blood of the enemy. Okay. So these are our three attacks and our three keys. So F, G, and H. And I have commented those, or the names of those attacks, so you guys know which key stands for which attack. Alright, sorry, I had to go AFK. Yeah, so these are our keys. Now let's move on with... let's add some kind of cooldown. So I'm creating a new variable, a bool value in this case. And we are going to check if this value is set to false. from the beginning. So by default, it of course is set to false. But when you try to use an attack, we are going to set this value to enabled. It means it is going to fail these checks right here, you know? And therefore it is not going to use the attack until this is set back to false again. And we now can decide when we want to set this thing back to false. And that is going to be our cooldown. So you basically decide how many seconds it will take in order to set the enabled value back to false. So for the laser eyes attack, I'm gonna enter a 3. So it is going to take 3 seconds in order to set this back to false. And yeah, you can now do the same for all of the other attacks. You can increase it, decrease it, depends on what you want to do. And yeah, so that's about cooldown and all these things. Now, the last thing we want to do is that we want to fire server these remote events. So the first fire server right here has laser eyes as its first argument, telling the script, of course, which kind of attack it is supposed to create. Now the second one is going to have the freeze, and the third one is going to have the bloodsuck. And yeah, that's it. Alright, now let's switch back, or let's go to our attacks script right here. And yeah, on server event basically means that it detects when this remote event has been fire servered, which is the case when we press any of these keys, so F, G, and H. So if any of these keys have been pressed, we are fire serving the remote event, and this script now can recognize when this remote event has been fire servered and receives all of the arguments. So the first argument, which is not being passed manually, right, which is not being passed right here, but it is being passed automatically, so you're not supposed to write it down or anything. So the first argument is the player. The second argument is the argument which you have written inside of here, which is either laser eyes, freeze, or bloodsuck. And I'm gonna call this val. And in this case, it plays a huge role because it is some kind of task to the script. So it basically tells the script to create the laser eyes or to create the freeze. So it is giving out tasks if you consider it a little. So if value is laser eyes, then this laser eyes thing is going to be created. Now, if value is freeze, then the freeze attack is being created, and if value is bloodsuck, then the bloodsuck attack is being created. Okay. Now, the next thing which we are going to do is that we are going to script either one of those attacks. Let's start with the laser eyes, and we need to export these animations which we have created in the last video, so if you can remember. So go to these 3 dots, load the animation, and again you're not able to see it, but yeah, so this was our laser animation right here. And yeah, let's export this one. Laser, submit. Okay, I'm gonna copy and paste the ID down here. Okay, so this is our laser attack. Okay. So we are going to create an animation. Well, instead of just typing everything, we can just go inside of this control script. No, inside of this React script, and then just take over these things. Then just replace the animation ID and the animation is going to play. Okay. But before we do that, I want to create another mechanism which is supposed to pick out a victim, a possible victim. So you could possibly just fire the laser in front of you, and if you're lucky, then you are going to damage someone. If not, then not. But I prefer another method for these purposes, and I'm going to pick a victim. So how is this going to work? I have created this empty variable, and we are going to loop through the workspace. So workspace get this descendants. So we are basically getting everything instead of the workspace, you know? So everything, even other players' characters, NPCs, you know, so everything. And we are now going to check if the thing we are currently at is a humanoid. So if the thing we are currently... So you gotta imagine that this is some kind of table, and you're looping through it, and the instance you're currently at. So we are basically checking if the instance, which is V, to which we, or at which we are currently at, is a humanoid. And if that's the case, then we have found something we can damage. And then we can just say, yeah, victim equals V parent. And that's how you find your victim. But there's another thing we need to consider, which has to do with distances, etc. Yeah, so how can we do that? Enemies nearby. So I'm gonna create a table called enemies nearby. And this one is going to hold all of the enemies which are nearby. So we need to check the distance between us and the enemies. And we do that by doing this calculation right here. So V parent, humanoid root part, position. So we are basically getting the position of our enemy's root part. And we say, yeah, this position minus our position. So character, humanoid, root, part, position. And this calculation right here would give out a vector 3 value. And by setting this inside of this magnitude, we receive a number. Wait, let me call this let me call this thing distance. And let me set this table up here. Distance. And we want to see... Wait. Alright, guys. So we need to find the enemy which is pretty nearby, which is the nearest enemy to our player. So we lock this distance thing, and now we store it. Oh, wait. It is pretty easy. Nearest enemy, let's say. Okay, it is currently at no. Is this even a thing? Mafuge, let's say. So a pretty high value, okay? Pretty unrealistic, etc. So why do we pick this one? You will see now. So if we would pick 0, then it would not even pass this if check, which we are going to create right now. So it would not check it. It would not pass it, and we wouldn't have, or we wouldn't receive an victim, you know? And this if check I'm talking about is basically checking if the distance of our current enemy is greater than the distance of the past enemy. And the past enemy's distance is being stored inside of this nearest enemy variable. And for the first enemy in our loop, so you gotta imagine that it starts somewhere. And the first enemy had no enemy before, you know? And therefore there is no number to compare. And if we would say that this thing, that this distance right here, that the distance of our enemy before is 0, then it would not pass this check, because every distance is greater than 0, so it would not pass this check. Therefore, we need to pick a pretty high number, which is math.huge. Okay, so distance. So if distance is not greater than nearest enemy, then nearest enemy equals distance. So we are basically expressing that if the distance, or if the enemy currently is nearby and even more near than our past enemy, then our current enemy becomes our victim. Alright, and you gotta imagine that it loops through several enemies, and it does the same, yeah, to all enemies right here. Okay, and in the end, we are saying that if nearest enemy, then victim. Wait, now I forget. Now I forgot to set. Yeah, never mind. Yeah, victim. The parent. Okay, so not only, so we do not only set the distance, but also set the victim to the current enemy, and at the end, yeah. So at the end we have we have successfully picked an enemy. Okay. Okay. Print. Print victim. Victim and its distance. And we need to ensure that we are not looping through our player. So if V is humanoid and V parent name is not our player's name, then we can proceed. Remote is not a valid member of local script. Yeah, okay, pretty nice. Wait for child, remote, there we go. So vampire mask is not a valid member. V, oh, is a humanoid. As you can see, it has chosen the dummy, because the dummy was our nearby, yeah, was an enemy nearby, and so that's how this victim choosing system works. And I'm going to do this one on all of these attacks. Okay, now the next thing which I want to do is that I want to turn our player towards the enemy. Where did I left off? I just went AFK. Yeah. Yeah, so we wanted to make our player turn towards the enemy. So in order to do that, we need to set a new C-frame. So I have done this in my enemy tower defense video as well. So C-frame.new. So our new C-frame is going to consist of our humanoid root parts position. So character, humanoid root part position, and our enemies humanoid root part position, or our victims humanoid root part position. And now we are saying, yeah, script.parent, character set primary part C-frame, new C-frame. Wait, what is going on here? Yeah, brackets. Okay, let's see if this has worked. There we go. Okay. So it plays the animation, it turns towards our victim, and it chooses a victim. Alright, so I don't know where I have left off, but... So I went AFK again. Yeah. So we should create 2 parts. So I'm gonna create a loop which loops 2 times. And with every loop, it is creating a part. And this part is going to be the starting point of the laser beams. Part character. So axe material is going to be neon. Axe brick color is brick color.new. Brick color is going to be magenta, let's say. Axe transparency, let's set the transparency to 0.3. Let's set the size to something pretty small. Yeah, let's say 0.1. Make sure that your part, the can collide is set to false and anchored is set to false. And let's create a new variable, a new instance, which is going to be the veld. And this veld is going to be inside of X. And what this veld does is that, well, X is our part. So it is going to veld the part to our head, especially to our eye, to be pretty detailed. So we are going to make the laser beams being shot out of the eye. And we are going to create some starting points, so some, yeah, little light beams on both eyes, which is our X part at the end. And we need to attach these parts to the eye or to their head. And we do that by welding them. And the part 0 is the part to which our starting points are being attached to, which is the head, because we do not have eyes as parts, but we do have the head as a part. Therefore, character head. So we're referring to the character's head. Now, part 1 is the part which is being attached onto something, which is our axe, means our starting point part. Alright, now there comes something, well, something not complicated, but, well, I don't know how to describe it. Well, a little change, let's say, but before we realize that change, so before we do that, I have to do something else. So I'm basically setting the C-frame of these parts, and I need to experiment a little around just to see how the parts look like when entering the numbers. As you can see, they need to be right there. So they're obviously not positioned correctly. Okay, 1.25. Now, what about now? There we go. There we go. All right. Let's reduce this to 0.75. Let's test this whole thing out again. All right. We are getting pretty close to what we want to achieve at the end. So maybe 55 or 55. Okay, so that's obviously, well, no. That's, well, let's add a little bit more. And now, since we almost have the perfect positioning, so I'm gonna add the part which I tried to describe earlier, which is not complicated, but it is a little bit unusual. So we are creating a difference between the first loop and the second loop. So in both times, or in both loops, we are creating a part and creating a veld, but we want their position to be different. And we do that by checking if this is currently the first loop or a second loop. And I describes, so I is the index, and this one represents the amount of loops we have already achieved, let's say. And if I is 1, then we are currently at our first loop. And if we are at our first loop, then I want this part to be either on the right or on the left eye. I personally cannot tell by just adding some random numbers to it. I have to see myself. So as you can see, this thing is currently at the player's right eye. And there's this other part, as you can see. And this one is going to be added to the left eye. So let me make this a little bit more bigger. Let's add to the second case. So for a second loop, we want this to be the exact opposite. There we go. Well, these are a little bit too big. Let's just keep them at 0.2. And now one more thing we can do is about C-frame angles, is about randomizing their rotation to make them look more cooler overall. So math random. So I'm basically just adding a random number for the degrees of the rotation. Let's hope that this has worked or works. Yeah, okay, it does not work. Okay, never mind this one. All right, yeah. So we have just added those eyes, those starting points. Now we need to add the laser beam. So that's it with those starting points. Now 2 more loops for the beam. And yeah. Going to make them a little bit more smaller. Especially on these axes. And I'm going to make it much more longer. Okay, let's see how this looks like. Wait. I need to add them right here. And I need to create a tween. So game get service, tween service. So if you don't know what a tween does, tween basically, you gotta imagine that we currently, when we create this part, it currently is, well, you need to think about 2 states, okay? So the first state is your default state. So default attributes, etc. And your second state is a state you want to achieve. Let's say that you currently have these sizes, so 0.1, 0.1, and 1, and you want this one to be a 10, for example. And you could just possibly say, yeah, x dot size dot z equals 10. So you could try to express that, and it would work, but it would like suddenly go from 1 to 10, and there would be no transition in between. So you would switch from the first state to the second state without any transition in between. And what tweeting does is that it creates that transition, which is missing when using other methods. And in the past, I tried to do the tweening. So I did not know about tweening, etc. So back then, when I did my Gomu fruit video, I tried to do something like tweening. So I tried to create that transition by using for-i loops. And tweening is the best method, in my opinion. So I did knew about it, I have learned about it, and it is the best method when you want to do something with transitions, etc. So tweening. So we are referring to the tween service, and we are creating the tween. And the first argument is the instance on which we want to perform the tween. The second argument is the tween info, which contains time, information about the time, easing style, easing direction, and so on. So you can just read it out for yourself. So time, let's say 0.5. Unum easing style, please. Easing style. Linear, unum easing direction, out. So repeat count 0. Reverse is false, and delay time 0. Now, the third argument is the second state I was talking about. So you basically grab a property. I'm going to grab the size. And I'm going to say that the second state has a size of 0.1, 0.1, and, well, maybe not 10, but let's say 8. And wait. So the weld right here has to move along, or has to increase along with the size, otherwise it would not look well. So how will we get this to work? Let me just quickly copy this one. Let me add it right here. So right at the end. And wait. Let me set this to 3. Wait. So first of all, let's just see how this tween looks like without influencing the weld C-frame. So in order to make the tween happen, you just type tween play, as I've done it. As you can see, the beams have increased, and yeah. Let me copy these two things. So we obviously need to add. Oh, yeah, so we need to add the weld into it. Okay, so this one is going to be a little bit more difficult, but we'll surely find a solution for that. C-frame. Yeah, well. Oh. Okay. Yeah, so we have to do it this way then. Okay, let me increase this to 5. Okay, 5 is too much. Wait, let me keep this at 1. Let me reduce it to 4.5. Yeah, there we go. So there's this beam being fired out, as you can see. It does work. Now we could increase the time it takes to finish this tween to 1. And I'm going to do that because I'm also going to add some other changes. So I do not only want the size to change, but I also want the transparency to change. So another aspect is going to be the transparency, and that one is going to change to 1 completely. So it is like going to increase by the size, and it is not only going to be longer, but it is also going to increase in its width and height. And it is like going to fade away. So that's what I want to do. Yeah, so maybe that was a little bit too much. And the beams are not long enough, I think. Let's increase that to... yeah. Oh, wait. Wait. I've just got an idea. I have just got an idea. Nearest enemy. Okay. If distance and distance is below 20. Okay, so 20 is going to be the ultimate cap. Okay, and this one is going to be nearest enemy divided by 2. Okay, let's see how this will work out. So this could become quite interesting. Okay, wait. I have to see this again. Okay. So my idea was to make the beam concept, or yeah, just be as long as the distance between those two players, or the enemy and our player. And since we have that nearest enemy variable, which represents the distance, we can easily do that. Okay, wait. Vampire attacks attempt to index null with... oh, okay. Yeah, because the distance was just too big. Too great. If victim is nil, so we need to add a check, which makes sure that there is a victim, and if there is no victim, then we basically just return. So we just break, we just cancel everything, and yeah. So you need to make sure that a victim is nearby. As you can see, he has attacked the victim. Okay. Now after attacking, we need to clear up everything, and we need to deal damage in the first place. So, victim, humanoid, take damage, math random, so I'm just gonna add some random numbers inside, and yeah. There we go. After 2 seconds, I want to clear up everything. And by clear up, I mean I want to stop the animation. loader stop. I want to destroy the animation, and I want the player to be no, and I want wait. Yeah, well, wait. We can make them clear up by themselves. Game debris add items. So by doing so, we are referring to the debris. We are adding an item, and this item is going to be the axe. So our starting point, and this one is going to go inside of this trash thing. So it is going to get cleared up after 2 seconds. So this is what this code right here expresses. We can use that for here as well. So this one is going to vanish after 2 seconds as well. So we do not need to clear them up manually. And we should make sure that the player is able to walk and jump normally again. Okay, vampire mask. And there we go. As you can see, it does work pretty fun, and it does look pretty okay, pretty cool in my opinion. So yeah, so nothing too special with very complicated camera movements. So it is of course pretty basic, but it does its job, you know. Okay, so that's it with the first attack. Now to the last 2 attacks, which hopefully are a little bit more easy. Alright, so let's get started with them. So we use this victim thing right here again. But this time the distance is more smaller. And this time our player is being teleported in front of our victim. So we are basically saying that our humanoid root parts C-frame equals our victim's C-frame multiplied with another C-frame which makes us stand in front, multiplied with a C-frame dot angles which rotates us towards the victim. At least I hope so. We of course need to test this whole thing out. Okay, let's see how this looks like. So let's first of all, yeah, there we go. Do this move on it, and now, okay, G does not work. H, why isn't G working? Oh, there we go. Now it does work, and yeah, we are teleported in front, right in front. We also should disable the movement of our victim. Basically just these things, but also for our victim. And we need to add an animation. Yeah, of course, I need to export our animation, which we have already created in the last episode again. Export. There we go. Okay, let's see how this is going to look like. Yeah, we should probably step a little bit more backwards. And I was just wondering why I wasn't able to use the move right here, but it is quite obvious because the distance between the next enemy is just too great. So we really need to be like pretty nearby in order to perform this attack, as you can see. Wait, that's not what I wanted to do. Alright, there we go. So now we need to make our enemy right here freeze. Okay, how's this going to work out? So I'm just going to do the following. I am going to loop through the victim, so the victim's character, and I'm going to clone the upper torso and the left upper arm, and I'm going to make them look like ice. So we are looping through the victim's character, and we only want to see, or we only want to use the upper torso and the left upper arm. So if we encounter these things, then we want to proceed. So local X, V clone, and we should rename these to v.name ice or frozen. And yeah, so X brick color.new, medium blue, X material equals glass. So we try to create this ice appearance, and X size equals X size plus vector 3. So basically the current size plus, yes, just some small numbers. Now we want to, weld this whole thing onto our upper torso or left upper arm. W port 0, please. V and W port 1 equals X. Okay, let's see how, well, there's still one more thing regarding the transparency. Yeah, let's see how this looks like, how this has worked out. Okay, so there's nothing. Okay, interesting. Wait, but why isn't this working out? Victim get children, or the parent, yeah, so this is of course supposed to work. Why isn't it working as expected? V.name. Yeah. So where's the issue? Do I need to parent this, or... So, what is the reason? Yeah, okay, there we go. Yeah, so we had to parent it. And yeah, so the numbers are a little bit too great. Alright. Now, so right here again, let's add them to the debris. So they are going to be removed after 2 seconds. And after 2 seconds, we once again want to stop all of these animations and want our player to be able to walk and jump again. And the same for our victim, of course. And we want our victim to receive damage. Okay. Now to the last attack, which is also quite easy to do. Yeah, because I'm just the one who just makes them easy. So I could make them complicated as well, but we do not want to have a 4-hour video right here, you know? So I could, of course, work with camera movements and, you know, make the camera shake, make the camera focus from another angle, etc. But that would just be, yeah, I'd say too much. So it would probably take 4 hours to record something like that. I don't know. But maybe one day, I will do that, but yeah, I don't know yet. Okay, so we are holding this one. Okay, now let me call it hold. Let me call this one hold as well. Okay, so the plan for this attack is to hold the player again and to make the player receive damage. And if we have received damage and therefore have less health, then the amount of damage we deal to the player, so that amount is being added onto our health. Means we are basically sucking out the health of our enemy and adding it to ourselves. And in order to do that, I wanted to create a random number, math random, which is which just picks out a random number of our victim's health. So victim humanoid health just picks out a random number. And now what happens now is that wait. I'm not sure if we are able to use the tween service on this one. Let's just try it out. Let's see if we are able to do that. That would be pretty cool, to be honest. So victim humanoid. Of course not 1 but 5. And the properties are health, which equals the victim humanoid health minus random n. Maybe 5 is even too fast. Let's increase this to 10. And let's create another tween. So tween 2, which is supposed to regenerate our health. So character humanoid health, character health plus random n. And now we make both tweens play. Tween play. and tween 2 play. And there we go. Now let me just pretty quickly clear these things up. Let me set this to 11 seconds. And yeah, so let's check this out. Let's see how this looks like. So let's just go through all of these attacks. Okay, our first attack. Now our second attack. And our third attack. Yeah, okay, 10 seconds are obviously too much, way too much. Okay, so let me just put this to 4 instead. There we go. Okay. Yeah, so the dummy is obviously dead now. Alright, so that's it with the video, guys. That's it with the attacks. Maybe one last thing regarding this vampire mask. Maybe we should add a cooldown here as well. Enable false. If enabled equals false, then enabled true. Yeah, that's actually it. So there's no go back. There's no turning back after clicking on the vampire mask. All right. Alright, that's it with the video, guys. I hope that you have enjoyed it. If so, please leave a like, subscribe, share this video to all of your friends. And that's it with the Vampire Mask tutorial, guys. If you want to see more JoJo tutorials, then give me suggestions in the comment section about possible JoJo videos I could create for you guys. And thank you for your overwhelming support. We are currently pretty close to 8,700 subscribers. Thank you for that. And yeah, take care, see you in the next video. Also, there's a link to the model in the description, guys. Go check that out if you are too lazy.